Question B says sketch f of x equals 2 over x plus 3 by writing it as a single fraction and determining the local and global behavior for the function. So now we're going to look at our kind of new way to do it rather than transformations. So we have the same thing. This is part B. F of x equals 2x plus 3. So to first write it as a single fraction so that we can have it in the form p of q over, or p of x over q of x. So that's what we're going for. We want it in this format so that we can get our rules that we just went over in our little checklist. So we would have make this be a common denominator, x over x, and then we get y equals 2 over x plus 3 of x over x, and finally y equals 2 plus 3x over x. And we just want to rearrange this now to be in descending order. So we would have 3 of x plus 2 over x. So that's the same fraction. It'll come out to be the same graph, but we're going to look at the local behavior and the global behavior. So we're just doing the same thing in a different way. So we want to have it in this format. So we're going to look at local. And then we're going to figure out our zeros. Okay, so I'm looking at zeros will be when p of x, the numerator, equals 0. So we're going to set 3 of x plus 2 equal to 0. Sometimes we have to factor, but in this case we don't. We're just going to end up with x equals negative 2/3, right? So that is when y is 0, so we're going to write that as a point. Negative 2/3, 0. We only have 1, so that's good there. So we're looking at all our different pieces here. Let me mark them up. Okay, zeros, and then we want vertical asymptotes are next. Okay. And what we want to do for that is set our q of x, our denominator, equal to 0. This was numerator. Okay. So set denominator equal to 0 because that's a situation where we can't touch, the line can't touch through at all, okay, or the curve. And in this case, it would just be 0. We always write this as an equation because we're looking up here. Okay. So it's always x equals something, right? So x equals 0 in that case. And then we're going to look at the wholes. Let's see if we have any. That would be a situation, let's look back up at our function, if we had factored and we have the same exact factor in the numerator as the denominator, that would make a whole. So we don't have one in this case, so make sure you do answer that as none. So I don't think you just didn't know or skipped it. So now we're going to look at the global behavior. All right, and our choices are for what the horizontal asymptote might be, or if we have a slant asymptote. So we need to look at the degrees of each. Now I have the same power, so if you look back at that beginning sheet that we had were looking at earlier, that we can see that they have the same power in the numerator and denominator. So we're going to be looking at the coefficient, which is actually just 3. So that's always going to be y equals something. And we write it as a line. So y equals 3. So we have the same power. So coefficient of lead is what we're finding there. Okay, so that's how we picked apart all the pieces, and then from that we could actually just sketch a graph on that too. We've already got that done, but let's just reference back up there. So I could have sketched in my asymptotes is what I would have done, right? I have that one, I have this, vertical one, and then I know kind of how they sit. I know it's to the first degree in the denominator there, so that I would have opposite directions here on my arrows that approach. This one's going down, so this one would definitely need to go up. So that's how I know where that sits. I also know that I have a 0 here, that it crosses through at -2/3 0. So we can even be more precise here. So we know that 0, we mark it in. We know our key points should be situated there just by the behavior of the parent function. So that's it for question 1 for tips if you wanted to go back through in a slower version. If you had already watched the other videos, this might help you get a little more solid. So have a great day.